So if I look at the word basketball, here, how many different 10-letter arrangements can you make with the word basketball? Normally what we would have done is done 10 blanks and we'd say 10 factorial. We agree? Because up until now we'd have no doubling or triplings, right? Okay. Are these two words different, basketball and basketball? No. I switched the L's, right? Totally different words. It doesn't say basketball, and no, they're totally the same, right? So what would suck is if we didn't have a way to get rid of all those ones that look the same, right? Because if that was the case, if we couldn't get rid of quickly all those ones that look the same, we would actually have to like do cases and be like, oh, okay, if I switch these two L's, then these two would be the same, so I have to take that one off. Like it would take forever, right? So there's a really easy way. All you do is you treat them like they're all different. So the very first thing I'm going to do is write out the word basketball. B-A-S-K-E-T-B-A-L-L. The reason why I write this out is now I know I have two B's, two A's, and two L's. We agree? So how we do it is we treat it like it's a totally different word. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That all the letters are different, okay? We're pretending that all the letters are different, that there aren't two L's, and there aren't two A's, and there aren't two B's, okay? They're all different looking. That's what we're pretending. So if we went to rearrange the word, it would be 10 times 9 times 8 times 7 times 6 times 5, 4, 3, 2, 1. Did I put 11 blanks? Which is 10 factorial. We agree? But we know that this isn't the case. We know that the answer isn't 10 factorial because we do have basketball, and I swap two L's and they look exactly the same, right? So that's why they'll say how many distinguishable. What that means is how many different words can I make? When they say the word distinguishable, that's all it means. Ones that look different. You can distinguish between the two words as being different words. Okay? The fastest way to get rid of them is you just divide by the repetitions factorial on the bottom. So what does that mean? I have two B's. Okay, so we have two B's. So we do 2 factorial for the two B's. We have two A's, so we do 2 factorial for the two A's. And we have two L's, so we do 2 factorial for the two L's. What is 2 factorial technically? 2, right? So on the bottom, we would actually have 2 times 2 times 2, which is 8. Some people want to go, well, can't I just do 6 factorial because I have 6 letters? 6 factorial is 720. 2 factorial times 2 factorial times 2 factorial is 6. Am I going to get the same answer if I do 6 factorial? I mean 8. Wow, that was really bad. 2 times 2 times 2 is 8, not 6. Still not getting the same answer. We're dividing by 720 or 6. And a little bit different, okay? So you have to actually do each letter differently. Now, this is what I also see in people's calculators, that they get it wrong. So they go 10 factorial, math, and then they go divided by 2. I'm going to do this just to prove a point, but I wouldn't put the factorial because I know it's 2 and I'm lazy and I don't really want to type it 3 times. Times 2 times 2. And then like, boom, that answer's on my diploma. I circle it, I move on, and I'm so wrong because what's your calculator doing? It's doing order of operations. What is it doing? It's going 10 factorial divided by 2, and then doing what? Taking that answer, timesing it by 2, taking that answer, timesing it by 2. Is that at all what I want it to do? No. So I'm going to go up there, I'm going to steal it. And I'm going to go second, insert, bracket. Oops, in the wrong spot. Then I don't have to retype the whole thing. Very big answer, but now it's actually right. The other one wasn't right. Does that make sense? So it's very important that you do the brackets or you will get the wrong answer. So it's 453,600. So if you tried doing the cases, I think you might miss a few thousand, right? Or maybe 100,000. So we don't want to do cases. We want to find a different way. Okay. So that's why it says a set of n objects with A of one kind that are identical and B of a second kind that are identical and C of a third kind that are identical can be arranged in, you just do n factorial, however many there are, and you divide by their factorials on the bottom of the repetitions, right? That's all we do. So what happens when they give us something like aardvark and they say the A's must be together? So let's first off write our word out. A, R, D, V, A, R, K. And make sure, like, when you're doing words that you check back and that you got all the repetitions. Because sometimes people are like R and then they put another R over here and they're like, ooh, we don't have any repeating, right? So make sure you check and make sure you count how many letters there are twice. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have 8 letters. I know that. So I know I'm going to have 8 blanks. 1, 2, 3, 4, 5, 6, 7, 8. And they told me what? The A's must be together. Did they say at the front? No, they need to be together. So I have 3 A's. I'm going to hook them together. Now, what did I tell you to do? Treat it like all of those letters are different. We agree? And then at the end, we just divide by the factorials, and they'll get rid of all the issues of them not being different. So how many A's do we actually have? 3. So in this blank, how many options would I have for A's? 3. We are pretending that they're all different. Are they all different? No. But we're going to pretend they're all different, and then we're just going to divide by 3 factorial on the bottom, and it'll get rid of all the issues where they're not different. Okay? How many would I have left for this blank? 2. And then 1. And then how many letters do I have left for the back? 5, 4, 3, 2, 1. Now, they will have that answer on the diploma. I'll give you the 4 common answers that I promise you they're going to have. They're going to have that answer. Multiply those out, done. Okay? Wrong. They're going to have this answer. This divided by 3 factorial, 2 factorial on the diploma. Wrong. Why? You still need to move them. It didn't say A's together at the front. It says A's together. So you have to move these. So you have this way. 1, 2, 3, 4, 5, 6. Remember, it's always one more than this number. So times 6. Then they'll have that answer, which is the right one. And what do you think they'll have that's another wrong answer? Yeah. Do the entire top, but forget to divide out the repetitions. There's your 4 answers. I can make an answer key to, I can make 4 easy answers to this test where you can make common errors. Yeah. Most people don't screw that part up, like, because they read the together part, so they're going to try and put them together somehow. If that's the person, they just are totally out to lunch. So they'll just end up circling something, right? Because they're way out. But most of the time, people read the together and can put it together, but they forget to move it or they forget to divide it. Okay? So the answer to this would be 6 factorial, 3 factorial over 3 factorial, 2 factorial. These 3's can actually cancel. So it would be 720 divided by 2. Hello, 360. We have Vancouver. V-A-N-C-O-U-V-E-R. Really? That's the only double? It's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, starts with the V's. So we can hook them together, but we don't have to move them, right? So 2, 1, and then 9, 8, 7, 6, 5. Wait, how many letters are there? 1, 2, 3, 4, 6, 7, 8, 9. Wow, I was doing like 11. Oops, go away. Seven, 6, 5, 4, 3, 2, 1. Divided by 2 factorial. Shh. So you get 2 factorial, 7 factorial over 2 factorial, which is which is, I think, 5,040. Okay, mathematical. Mathematical. 1, 2, 5, 6, 7, 8, 9, 10, 11, 12. So what I do instantly before I even deal with the top is I draw it over and then put my factorials. 2 factorial, 3 factorial, 2 factorial, just so I don't forget them. How many vowels are there? Close. 5. So we have 5, 4, 3, 2, 1, and then we have 7 left. 7, 6, 5, 4, 3, 2, 1. And then what do we have to remember? Multiply by 8. So it's going to be 8 factorial, 5 factorial over 2 factorial, 3 factorial, 2 factorial. When you have more than one factorial in the top of the bottom, I put them in brackets. And what do you get for an answer? 10,685. Wow. It has to be bigger. To what? That? It's like 201 and then 100. That's what I heard. Everyone starts off strong, or they'll be like, it's 201,000. I'm like, okay. And then I'm like, sorry, I didn't get it. And they do it again. 201,000. I'm like, I'm not getting the end part. Please try again. Okay. So pathways. We're going to follow along so that you're not going to do this method, but so that you trust that it's true. Okay? Don't do the first way I'm showing you, because the first way I'm showing you is actually the pathway method, which wouldn't make sense to even do because you are in perms and comms, right? So there's got to be a way that this fits in the perms and comms unit, not just pathways. So once again, like we did those other pathways, we have to go from A to B and no looping, right? You're not going to just like stand and keep looping around one block, because then you'd have infinite number of paths. That's just ridiculous. So we're going to start at A and we're going to go to B, and now I'm a little bit dizzy from doing the circling. Start at A, go to B. So this is what we're going to do. You do not have to copy this method because this method is long, arduous, and you're not going to have to do it. Okay? So to get to this little cross section here, there's one way, right? To get to this cross section, one way, one way, one way, one way. We agree? You just walk to it. So to get here one way, get here one way, get here one way. You just walk that way, right? Because I can't loop back. I can't go like this way, this way. If I went this way, I'd be looping back. So there's one way to get there. There's also one way to get to each of these ones, right? You just walk to them. We agree? All we're going to do now is just sum up all of the different paths to get to the next cross section. So to get to this little dot here, I have one path coming in, right? And one path coming in. So how many paths total do I have there? 2 now. We agree? To get to this one, I have 2 coming in and 1 coming in, so I actually have 3. Then 3 coming in and 1 coming in, so 4. You don't have to write this one down. Remember, this is the long way, which is not going to be the way you're going to be asked. 4 and 1, 5. 5 and 1, 6. Then we come to here. Coming in, I have 1 and 2, so 3. 3 and 3, so 6. 6 and 4, so 10. 10 and 5, so 15. 15 and 6, 21. 1 and 3, 4. 4 and 6, 10. 10 and 10, 20. 20 and 15, 35, 35 and 21, 56, 1 and 4, 5, 5 and 10, 15, 15 and 20, 35, 35 and 35, 70, 70 and 156, 70 and 56, 126. So there are 126 different paths to get me there. Okay? That has nothing to do with perms and comms, right? So there's got to be a way that this is counted. So the way to do it is, remember how we did the fundamental counting principle with that other pathway where it was the curved pathways, and we did 3 and 2 because there was 3 parts and 2 parts, and we multiplied them and got 6 different paths on the top, right? Kind of the same thing here. We can only go down or right, correct? We can either go down or right to get us to B. That's the only way. We can't go back up or we'd be backtracking, and we can't go left or we'd be backtracking. We agree? So I have a down, a down, a down, a down. I have 4 downs that I could choose from. Or right, 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 right. We agree? So technically I have the word der. That's my word. We agree? If I take der and I find out all the ways I can make different words with the word der, I'll find out the pathways. So how would we do this? How would you figure out all the ways you could rearrange der? No restrictions. How many letters are in der? 9. So we'd have 9 blanks technically, and we'd have 9, 8, 7, 6, 5, 4, 3, 2, 1. We agree? So on the top we'd have 9 factorial. And on the bottom, what would we have? 4 factorial times 5 factorial. Try it out. And then it's like the clouds open and the stars align and everything's like, ah, and you get the same answer. Isn't it wonderful? Brings joy to children everywhere. Yeah. It's like Christmas. Okay. So 126. Now, here has 2 blocks, right? We're just going to do each separately. Then do you think we're going to multiply their answers together or add their answers together? Why? Because you have to go through. You need these paths and these paths to get you there. For this one, we're going to multiply because he's right. You have to go through these ones and these ones to get to the end. So this one, we'd have D, D, R, R. So we'd have der. How can I rearrange that? What would I get on the top? What would I get on the top? Or ridid, yeah. 4 factorial, because there's 4 letters, over 2 factorial times 2 factorial. And then this one would be der. You know, just that little bit better. Or ridid. Okay, so this one would be, how many on the top? 5 factorial over, what? Yes, I get what you're saying. But at first I was like, but you're just being all mathy and saying it's 12 in the end. I don't need this. I don't need no factorial. I got this. I see you. You're correct. Multiplication, yes. What do we get? Help me. What's the answer? All right. Next one. And then you have homework. Brett bought a carton containing 10 mini boxes of cereal. If only 10 came together. I think it's 6 or 8. There are 3 boxes of cornflakes, 2 boxes of Rice Krispies, 1 box of Cocoa Puffs, 1 box of Shreddies, and the remainder are Raisin Bran. Over a 10-day period, Brett plans to eat the contents of 1 box of cereal each morning. How many different orders are possible if in the first morning he has to eat Raisin Bran? I gave some serious emphasis on that one, you know? Emphasis on the wrong syllable. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, start with Raisin Bran. How many Raisin Bran does he got? 3, because the remainder were Raisin Bran. So he has 3 Raisin Bran options for the first one. Does he really have 3 different Raisin Bran options? He has 3 different boxes, but is it going to be a different experience for him if he picks one of the 3? Nah, he's got Raisin Bran. Very learned. Yeah. Okay. So I guess possibly if you get a box with harder raisins, it could be a different experience, but you wouldn't know. Okay. What do we have left? It's just starting. The first morning was Raisin Bran. 9, 8, 7, 6, 5, 4, 3, 2, 1. And then we divide by? What's we got on the bottom? 3 factorial for the cornflakes. 2 factorial for the Rice Krispies. And then 3 factorial for Raisin Bran. We can't forget about those. And what's our answer? How many different options of cereal does Brett have? What do we get? And go. Because it's not, he doesn't eat all the Raisin Bran in the first 3 days. Right? If it only would be 3 factorials if he had Raisin Bran, Raisin Bran, Raisin Bran. And then it wouldn't be 9, it would be. So what is it? Is that right? Oh, I was confused.